So, good morning to all. Today we will start actually formal data mining techniques we will talk about, and in last class I talk about the basic idea of data mining task, like how to measure the similarities and so on, and I said ki there will be one class on vector space. So, that will be deferred. So, in later on we will talk about the vector space model, okay, and then some metric operation. So, as I said in the beginning classes, like first class I cover the entire syllabus of the brief idea of the what is data mining and what are the data mining tasks. In that class initially I said ki we will have a different task, that is one of the important task is classification. So, today we will talk about the classification. So, in today's and then subsequent classes we will be cover is what is classification. Formal definition I already talked, but again I will talk about what is classification more formal way, and then very popular classification algorithm, that is decision tree. We will talk about the decision tree, and then we talk about the distance based classification methods. So, here we go. The formal definition of classification is second one, that is the definition, mathematical definition. Before that we will talk about the definition here, that is the task of classification is to assign an object into one of the predefined categories. The important here is predefined categories. Let us say we want to classify the students, whether students is undergraduate students or postgraduate student. So, that is predefined, whether students either postgraduate, even though students is doing PhD, we will talk that student is actually in postgraduate. So, that is we should have a categories in beforehand, that is something called the predefined categories. And then what is the task? Task is that we whenever new object come, but new object we have to new object means we have to identify the object's category, and then category means one of the predefined categories. Say I want to classify the animals, and animals are there are two types, let us say mammals and non mammals. So, we already defined that mammals, we should not go again within non mammals what are the other subcategories, because our categories are already defined beforehand. So, therefore, we should assign any one of the predefined categories. Okay. We will see some more example later on, and then we follow the formal definition, that is given a data set D of object, as we studied that what is data set. Data set is the set of objects. Okay. Set of object is called the data set. And how do you define the object? That we said is each object is recognized or defined as a set of attributes or characterized by a set of attributes. So, an object is nothing but a set of attributes that we have seen earlier, and then today also we will see little later. Okay. So, that is given a data object, that is given a set of data object and a set of classes, that is the predefined categories. Okay. So, we have a set of data object and predefined categories. Then what is the task? Task is to find a mapping. So, we have to find a function or mapping. Okay. So, that will map from the, so let us say you have a data set here, you have a data point here, and then we have another class. So, class let us say class C1 and class C2. So, then what is the task? We have to assign this object into any one of the classes. So, that is we have to find a mapping function f from, that is the data set D to the any one of the predefined classes, where each object is assigned to any one of the classes. That is the classical definition of that is the traditional definition of the classification technique. So, we should assign each object into one of the categories, not the multiple categories. Okay. So, this more formal way, a class is nothing but a precisely those object mapped with this function. So, what is this class? Class is nothing but the set of object, and that set of object basically mapped to the class J. So, now we will see some example here. So, okay, how it works? So, that is the formal definition of the classification. Okay. So, we should have a data object, and we should have a categories, and then we will map from the one categories to one object to the another, any one of the categories. But how it works? So, that is something I talked is like working principle. So, we will have a set of object, that is the data object, with their categories are defined, that is something called the training set. Okay. So, what is the training set? We have a set of objects along with the categories, any one of the predefined categories should be mentioned, that is something called the training object. Okay. And then what you have to do? We have to find a model. What is that model? Model is nothing but just few minutes before we talk about a function. So, we have to learn a function from the training data set. So, that is model is nothing but it captures the relationship between the objects and their categories. So, we have a predefined category, we have a two sets another from the set of objects. So, what we have to do? We have to learn a function, or we have to make a model that basically it captures the relationship between the categories and the objects. So, object is nothing but it has the multiple attributes. So, in other way around, so it finds the relationship between the attributes of the object and the categories. Okay. We will see little later. And then this is the task we have to do, and then what is the final task? Whenever a new object will come, then we have to identify the class of the new object, that is assign a class level, that is any one of the predefined category to an unknown object. So, we will see some example here. Let us say we will have a training data set. What is training data set? Training data set means we will have a class level of each of the object present in the data set. So, that is something is written is here, x is the object here, and x consists of a set of attributes, and y is nothing but the class level of the object x I, and class level means it should be predefined categories. Okay. And then this is the classifier, that is the classification algorithm. In this example today we will see the decision tree. Okay. And then from we have a training data set, and this from training data set will make a model. Okay. We will make a model, and then what we will do it? Whenever there will be any test set means we know the object, but we do not know the class level, that is the task we have to do. So, this object will consult with the model, and then finally, we will get the class level YL for the object XK, let us say. Okay. So, this is the summary of the classification technique. So, few example we talk about, that is the predicting tumor cell as cancerous or non-cancerous. This is a classification example, and then categorize the news article into one of the predefined categories. If you see the in Google News, okay, they also have the predefined categories, like you can see on the left side, that is they have the news like sports news, entertainment news, and then technology or scientific information and so on. Similarly, the political news, sports news, entertainment news, these are the predefined classes. Now, whenever new news come, then what you have to do? So, it will categorize any one of the predefined. It might be entertainment news, or it might be a political news, or it might be a sports news. So, one example, let us say suppose one article is there, say there something is written there Rahul. Now, Rahul belong to say either in it may be in political, it may be sports, it may be entertainment. Okay. So, based on the other information with Rahul, whether it is Rahul Gandhi or Rahul Mahajan or someone else. So, based on that it will be defined based on the other characteristic, based on the other text classification techniques. Okay. It will assign any one of the predefined categories. Then this example already I talked about, that is categorizing animals as the mammals and non-mammals. And then this is very popular way, classifying the emails into spam and non-spam. So, this is whenever there is only two classes, that is something called, this problem is called the binary classification problem. See here also we have that credit card transaction is legitimate or fraudulent. So, we have the two classes. So, whenever there will be two classes, that is something called the binary classification problem. But here it is a multi-class problem because we have more than 2 classes. Now, we will talk about few classification techniques. One of the approaches is popular approach is decision tree, that we will talk about little later. Okay. And then we have the neighborhood based approach. So, we will also cover in this case in this class. Then popular approach, as you know, that deep learning is very popular nowadays, and the basic of deep learning is here neural network here. So, these will not be covered in this class, but it will be covered in next semester machine learning course. And then the Bayes classifier, and then we will talk about the support vector meshing, and finally conclude the classification task with ensemble of classifier. Okay. So, we will spend around quite substantial time in this classification technique. So, at least 10 to 12 classes for the classification model. Now, we will talk about the decision tree. So, as I said just in the beginning of this today's class, that working principle of the classification techniques, initially it should have a training data set. That is, what is training data set? We should have a object here and then with the class level. So, this is something, this is an object, but this is something called, this one is called the class level. So, object we will talk about. So, and then I said is object consists of, object is characterized or recognized or defined by set of attributes. So, this is attribute number 1, this is attribute number 2, and this is attribute number 3. So, a guy is represented by whether he has refunded, he has history of refunding the loan or not, and then another is what is his marital status. So, that is single, and another is what is his income. So, these entirely represent a guy's profile, and based on that banker is decide whether this guy can be given, this guy can be given the loan or not. So, that is the categories whether he is cheat or not. So, here his task is to identify the, if the new person come with some information like let us say this is yes, yes he has the refund, and say marital status is married, and then income is let us say 180k. Now, we have to say whether this guy can be cheat or not. So, income is high does not mean that that guy won't be the cheat. Okay. So, therefore, this is the new object. So, this is something called new object. New object is what? The object which is not in the training data set is called the new object. So, this information is nowhere in the training data set. So, therefore, this object is the new object. The task of the classification algorithm is to identify the class level of this new object. And what is given? What is the principle, working principle? You will have the training data set here, and from the training data set you have to make a model, that is the number 1, number 2 and number 3. So, number 1 is training data set, you will have a object with class level. Okay. You can go back and see the slide. Okay. And second is you have to make a model. Model is can be a mathematical formula, or model can be a some decision tree kind of information and so on. So, you have to in other way around. So, you have to make a relationship between the attribute class level and the all other attributes of the objects. Let us say if we have a single attributes. So, and then we have to find the relationship. Says yes, if refund is yes, the cheat, he is not cheat. Then if the refund is no, so then this is yes. So, if you find only the attributes refund and the cheat, you will get a relationship, but that is not sufficient. You have the other also characteristics. So, including the all these attributes, you have to come into a conclusion or in a relations, what is the relationship between the categories and the all other attributes here. So, that is the model. So, in decision tree we will make a model, but decision tree here model in terms of the decision tree. We will see little later how to make the decision tree. So, in summary, we have a training data set where we know the attributes values and the class level. Here nothing is unknown here. And then what you have to do? We have to make a model. And once model is built, you use this model for identifying the class level for the new object here, that is new. Okay. Now, we got a decision tree. How do you get it decision? How do you get the decision tree? That we will see a little later. But let us say we got decision tree somehow. So, this is the decision tree refund. Refund is attribute. Okay. So, if you see carefully here in the decision tree, so all internal node here 1, 2, 3, all internal node is nothing but the attributes here. And what is the branch? Branch is the outcome of this attribute test condition. We are testing refund. Okay, refund is having two values, yes or no. Okay. So, if it is yes, so then we should go some another node, and if it is no, then we will go to this one. That we will see little later. But let us say we got the decision tree, and how do we identify the class level of the new object? So, what you do it? We have a training data set, we got the decision tree, and then we verify the example, that is the new. How do you get the class level? So, here let us say in this example, this is the new object. As you see, refund is no, and then status is single, and then income is 81K. We have to identify the class level. What is given? Training data set we had. Now, out of the training data set, we made the decision tree. Now, we have the decision tree. Once we get the decision tree, we should not look into the training data set for decision tree problem, but it varies from the one application to another application. Let us say in the distance based classification algorithm, always you will consult with the training data set. But in this example, once we build the decision tree, then no need to look into the training data set. So, now we have a unknown object, that is the new object. We have to identify the class level. How do you do it? Refund value is no. So, what we do? We will go to the root of the decision tree. What is the root? Root is refund here, but it can be anything else. Decision tree can start with any one of the object, let us say with the marital status. But fortunately or unfortunately, here we got a one example where decision tree is having the root is refund, and then first attribute is also refund. So, refund, then what is the value of no? So, then it should go on the right side. And then what is the marital status? Marital status is single. So, it is this marital status has three values. One is single, another is divorce and married. So, it can have three branches, but in this decision tree we have two branches. So, in one side is single and divorce, another side is married. So, because value is single, so we should go on the left side. And then we consult with the income. What is income? 81K. Income value is 81K, is less than 81K, it will go to the left side, but this will go on the right side. And then what is this one? Okay, this guy is cheat. Okay, so this is the results here. So, decision tree is very easy. Once you build the model, answer is very quick, just you trace the tree, you will get the output. Now, what you will look into the matter is how to make the decision tree. Now, these are the some good quality of the decision tree, that is, it is a very popular classification method, and model is interpretable. So, many times we want why this. So, let us say in recommender system, what we want is some product is recommended, but we are very curious to know why this product is recommended to me. Similarly, some recommender system, what it does, it will make you understand, or it is simply interpretable why this is happened or why this product is recommended. Similarly, this model is also interpretable simply, and it is a simple algorithm. Prediction accuracy is adequate for many applications, and prediction process is straightforward, and it can handle the nominal, ordinal and continuous attributes, and data needs to be fit in the memory. Means that entire tree should be fit into the memory. So, this is the assumption. And prediction accuracy is, they are not saying the prediction accuracy is the best, they are saying is the prediction accuracy as good as with the other classification technique. Okay, that is the something is to say is adequate for many applications. So, many applications still people use the decision tree, at least this algorithm was introduced in 1984. Okay. So, in the between there are very sophisticated algorithms, support vector machine, and now today is deep learning and so on. Still it is so easy algorithm, you can easily apply to the data set and see what results is coming, and then you can refine your result changing the other classification techniques. Now, formal definition of the decision tree. Obviously, decision tree is a classifier, no need to mention it. And what else? Decision tree has three features. that already I talked, but again I will repeat it here. A decision tree corresponding to a given training set T has the following properties. What is those properties? What are those properties? Each internal node denotes a test on the attributes. So, earlier I said is each internal is describing an attributes. It is not attribute only, it is the test condition of the attributes, because it is a binary attribute. So, if you write the attribute, so it can have only two values, yes or no, that is why it is not specifically mentioned. If it is, let us say, in other continuous attributes, so the test condition could be written, that will, let us say, income. If I write, so the if we write only income, that is not sufficient. So, let us say if we write income greater than 80, then you go left side yes, on the right side no. Okay. Then each branch represent an outcome of the test, and then each leaf node hold a class level. So, now we move back here. So, it has three properties. What is? Each internal node represent the, this is internal node, this is internal node, and this is internal node. This each internal node represent an attribute. So, this is the attribute, we can say refund. So, this is refund is another attribute, marital status, another attribute is income. And then what is the outcome? Outcome is the test. We are testing refund, we are testing refund yes or no. So, this is the outcome is yes or no. Similarly, marital status is combined single and divorce, another is married. And similarly, income here, income test condition is whether it is greater than 80 or less than 80. So, that give you the left side and right side value. So, that is the three condition we got it here. So, one is attributes, test condition, outcome, and then class level. So, if you go back here, so all that is terminal node or leaf node will represent the class level. This no is not the here no, this no is basically represent the here class level no, or say let this yes is not the any other attribute value, these value indicate the class level. So, now we will talk about how do you build the decision tree. In just previous video, what we have seen, what is the working principle of the decision, working principle of the classification technique, and then we gave the definition of the decision tree. Okay. So, decision tree is a tree, but it has some specific properties that we discussed. It should have internal node should represent the attribute test condition, and the outcome of the internal node represent the outcome represent the outcome of the test condition, that branch represent the outcome of the test condition, and then finally, the each leaf node represent the class level. Now, how to build the decision tree, that is the from the very beginning I started talking how to build the decision tree. Now, here is the algorithm. Algorithm is very simple. What is that? Let us say T n be the training set associated with a node n. As we have seen that we have the refund, this is also a node. Okay. And then we have a node here. Now, we have that T n is the training set associated with a node here. So, we have a 10 sample associated with a node n. Okay. Now, this is trivial, first one is very trivial. If all records in the training data set belong to a single class, then the node n is a leaf node and the label as the class C1. So, after partitioning, if you see that all pattern here belongs to a, all objects belong to a single class, okay, then there is no need for again partitioning, further partitioning, and that work is very trivial. And then you identify what is the class level, because all pattern, all objects belongs to, all objects belong to single class, that is done. So, this is very trivial, as you understand also. Now, here we go. What is that? If T n records belongs to more than one class, that is obvious. You have a given training data set, you will have a multiple class, otherwise it is there is no task even. If all class belong to a single, all patterns or all objects belong to a single class, then you do not have any training data set. You have a training data set, but you do not have information of the other class or any other classes. So, that is not the problem, that is not the actual problem of the classification. That is T n records belongs to more than one class. Then what you have to do? An attribute test condition needs to be selected for partitioning the record into smaller subsets. So, you have a 10 data set here. So, you have a 10 data set here. Then you see is that classes of the 10 data set are different, not the all 10 belongs to single class. Then what you have to do? You have to again divide it into partition into subclasses. That is the algorithm it says. So, then what you have to do? You have to partition the records into the smaller subset, but how? You have to choose any one of the attribute for partitioning this one. So, in earlier example, if I go back there, then what we see is there are 3 attributes. So, we have chosen the refund is the first attribute and then we split it. And then what you have to do? Recursively apply the procedure to each subset. Again you see the each subset, whether all objects belong to single class, no need to do anything, then you directly you see what is the class level and that will be the terminal node. Otherwise, rest internal node again you divide them and then go on. We will see with one example in the next. So, this is something called the Hunt's algorithm. So, this is the training data set as we have seen earlier. So, this is one more, and then what you have to do is there are some issues here. So, is how to partition the record, that is we said is you partition the record into subset, but how do you make it and how to determine the best. Now, we split the data set into 2-3 subsets and then how do you do it. So, that is the splitting criteria. What is the splitting criteria? Splitting criteria indicate the splitting attribute with a split point, that is the state condition. And then what is the objective? This is the objective. Objective is to get each partition as pure as possible. Okay? We should make subset in such a way that each subset should be pure. Pure in a sense, most of the object should belong to a single class. That should be the objective. So, you may not reach that objective immediate partition, but your final objective should be that most of the or all pattern should belong to a single class. Let us say you have initially 10 objects here, you have 10 objects, now you partition into ES using some, let us say using some attributes, say refund. Now, you put yes and no, now here is 7 and here is 3, okay, because yes values of the refund is 7 and then no value is 3, and then out of this 7 you see the class level of this object and you see the all class levels are not same, then again you have to partition into using some other attributes. Okay. So, let us say now you use the attribute, let us say status, marital status. Now, out of 7 you 5 is here and then 2 is here, and you see the all 5 patterns belong to a single class. So, therefore, what you have to do it. So, this is 5 we said, right. So, this will be a class level, let us say C1, this will be another class level C2, and then all 3 belongs to a single class. So, this will be another class level, let us say C1, because 2 class problem. So, then objective is to get a partition where we will get the homogeneous objects. Now, there are few issues here. What is that? Depending on the different type attributes, so as we said in the class, we have the nominal attributes, ordinal attributes and continuous attributes. So, based on that we should do another way. So, whether we will go always with a binary split or we will go multi-way split. So, let us say the marital status we have 3 one is single, then divorce and then another is married. Now, whether if you use, we have 3 values. Now, if the marital status is an, let us say is an internal node. So, in that case what you do it, we should go for the 3 partition or we should go only the 2 partition, merging single and divorce should be 1 and then another will be married. So, therefore, should we go for multiple partition or should we go for the 2-way split? So, these are the issue for the decision tree. Now, if you have a continuous attributes, so that is really difficult. So, we have to discretize them, and one binary decision is income is less than 80 and above 80. That is we already told how to determine the best split. So, nodes with homogeneous class distribution are favored. Okay. So, need to have a measures of node homogeneity. So, now what we talk about here, say we are saying ki we should have a partition, we should have subset such a way that each subset should be as pure as possible. How do you measure this purity or homogeneous distribution? How do you measure? So, therefore, we should have a metric to measure the purity or impurity or homogeneity. Okay. Okay. So, now we will talk about the different metrics by which we can identify whether this, let us say we divided into two parts, this subset 1, subset 2. So, this subset is more pure than this subset. So, we should have a measure. Okay. So, that is we will see in the next. So, therefore, how to determine the best split? So, a metric is used for selecting the best split. As I said few minutes before that, what is the main idea? Main idea is that we should have a partition, so that each partition should have as pure as possible, or that each partition should have homogeneous, or we should have a purity measures. So, instead of purity measure, we can measure also impurity, and that will be the 1 minus purity. So, this is another way also look into. Okay. Now, there are three popular metrics. Okay. One is Gini index, another is entropy, another is classification error. So, using this one, we will compute the purity or impurity of each node of the decision tree. So, I stop here. In the next class, we will start talking from here how to compute the impurity or purity of each node.